This video is part one of a two-video series on balance outstanding. In this video, we're going to look how to calculate balance outstanding at a particular point along the timeline. Now, balance outstanding on a loan after a certain payment, for example, the Kate payment, just to generalize, it's the amount still owed. So how much do you still owe on this loan? Because sometimes people actually just want to pay off the rest of their loan, so they want to know how much they owe at that point. So let's have a look. The balance outstanding, which we're going to represent with a B, on a loan after the Kate payment, that will be a number, an exact payment like the 50th payment or the 100th payment. So after the Kate payment has been made is the amount still owed at this stage. So it's how much do I still owe right there, at just after the Kate payment. Now, there are two ways to calculate balance outstanding. I'm going to show you both methods, but the second method is the one I recommend because it generalizes to almost all the examples, whereas the first method becomes really tricky for certain types of examples. Let's just have a look at it anyway. The first method I'm just going to call the present value method. And that is, you determine the present value of the payments that are yet to be made, where n minus k is the number of time periods left. So if we have a look at the timeline, B would be our present value of all those payments that are still coming. And to know how many payments, you just take the n and you subtract the k to find out how many payments there are there. So that's one way to do it, using the present value formula. So you can see that we're taking it back to get that present value at B. Now that's a method I don't think that you should use, even though it seems simpler in some cases. Let's have a look at another method, and that's the future value method. Now in this method, you determine the future value of your P. In other words, you grow your loan forward for K months, 50 months or however many months or time periods you're dealing with. So you grow that loan forward. And that's just compound interest formula, because you want to see how much is that loan going to be with all its interest at that point. Then you subtract the future value of all K payments of X at TK. So it's the future value of all of these payments, that X, that X, that X, all of them up until that point, that future value of all K payments, including that one there. So then we're going to subtract them. So we want to know, well, P has accumulated interest all the way to there, but we take away the payments that have already been made and all according to the future value annuity formula. So that's what it looks like. So you've got your future value of P at K, and you subtract the future value of all K payments of X at TK, and that'll give you that value B at that point. And this is the method I recommend you use. I've just made another note, re-emphasizing that the first method may seem like a convenient method of calculating the balance outstanding. However, there's some situations where using this method would not be that easy. And once you start to try questions, you'll see this. So I recommend using the second method as it is more reliable for different types of problems. So now we're going to have a look at an example. And in this example, I used method 2. So in this one, we have a 20-year loan. So we've got a 20-year loan of 100,000 Rand is to be repaid by means of monthly payments of 2,000 Rand, an interest rate of 18% per annum compounded monthly. So there's our information. Calculate the balance outstanding, so how much is owed after the 50th payment has been made. So as with all our finance type questions, we are going to start with a timeline. So let's pop our timeline in here. There we go. Right, so in that timeline we know we're dealing with T0, T1, T2. Now I'm going to pop T50 somewhere over here. Remember, it's not ready to scale. T50, and we know it goes up to 20 years, and we're dealing with months. So 20 times 12 gives us 240. Okay, now we know our present value is 100,000, so I'm going to put it here. And what we're trying to find is our B, our balance outstanding. And then we've got payments of 2,000. Now, I didn't actually state in this question that it's the end of every month. If it doesn't state it, then assume that we're going to our simplest case, which is the end of every month. So I've got my 2,000, 2,000, 2,000, all the way up to the end. Cool. So there's my timeline, so I can visualize what's going on. Remember, we're using the future value method, which means we've got to start by taking that 100,000 all the way to that point over there at T50 when we actually want our balance outstanding. And then we're going to subtract all these payments up until that point using the future value annuity formula. So let's do that. Right, so our balance outstanding, our B, is equal to 100,000 and all its interest, so 1 plus 0,18 divided by 12, 50 months. We subtract the payments according to the future value annuity formula, so we take away the future value of our payments, which is 2,000, because those are our payments. Then remember it's future value, so you've got 1 plus 0,18 over 12 for 50 payments minus 1 divided by your interest rate. Remember, you can always work that interest rate out and plug that decimal straight in. Right, let your calculator do the hard work for you, and you should land up with 63,158 Rand and 59 cents. Now, if you're starting to think, actually, why could I not have used method 1? Of course, you could have. In this particular example, you could definitely use method 1. So I challenge you to go ahead, give it a try. You might find the decimals are slightly out. That's absolutely fine because of rounding along the way, because often that we're going to land up with a different decimal. But that's not a problem and would be totally acceptable in a test or an exam if it's possible to use that first method.